Hey there, and welcome to another episode of Richie's Robots. In this episode, what we're going to look at is a clock timer that I've gotten from my kickboxing gym, which is called a Thai gym. And the problem with it is the buzzer, the sound of the buzzer is way too low. So it effectively makes the clock useless because when we're sparring and so forth, we just can't hear the buzzer when the time is expired. We usually set a clock at a 1 minute or a 2 minute period with a 30-second or a 1 minute rest time between that. So it'll go for 1 minute, 30 seconds rest, and then 1 minute again, or 2 minutes or 3 minutes, usually with a 1 minute rest. The second problem I found with the clock is it's just very fiddly to program. So for instance, when you want to program this, you've got to edit, enter the numbers, so 99, then edit, then the time 00, and then you want to do OK, interval, edit, and then you got to set the interval, the rest time, and then you're okay to go. And then if you want to change it again, you got to do that whole process again. You got to grab the remote, go into the middle of the hall, and kind of muck around with it. I'm going to use an ESP32, and I'm going to pre-program those with some IR codes. So I'm going to work out what IR codes it uses and have the ESP32 automatically do that for him so that the trainer can just press the button and it will set the interval and get ready to go. So without any further ado, let's get on with it. All right, so we've opened the clock up. As you can see here, it has a standard 12 volt connector, which comes from here. Runs 12 volts straight into the board. We can tap into that for an external amplifier if that's required. We've got the speaker here. It's an 8 ohm speaker, runs at 1 to 3 watts. And we're looking at the output here. I see that it uses the LM386G amplifier chip, which is a linear integrated circuit. And the two top pins are bypass pins. And reading off the specifications, which you see here, if you bypass that with a capacitor, a 10 UF, capacitor, then you should be able to get another 48 decibels out of it, which may be enough for what we need to do. If you couple that with a resistor, you can control that variably, but I'm going to see if getting another 48 decibels is going to make the clock loud enough for what we need to do by soldering a capacitor between the two. So I'm going to find it out now, and we'll give it a test run. Alright, so as you see, we've put the capacitor in and soldered it. That's this one here. Now, because the soldering was very, very fine and the pins are quite small, we want to make sure we are not connecting the solderer with the second pins underneath it. So we've got the multimeter on connection mode, so if it detects a connection, it'll beep. Alright, so I'm getting some good sound out of it now. And I've got 4 speakers connected to it. With these small 4 speakers in a multi-directional way, you are, I think, getting enough sound, but I'm getting a bit of feedback and humming, and I think the chip is not grounding out correctly. So what I've got is I've got a bypass pin, which is the pin, let me try to point it, which is the pin here, this second one on the top, and I'm going to ground that. I'm going to ground that with a 10 UF capacitor to the ground pin, which is this one here, and see if this cleans up the signal. Alright, so just a quick little update. I found a better way to get rid of the residual humming, and that was to put a 10 ohms resistor in between, and you'll see it lowers the volume only a little bit, but it was already really loud. So I think this is going to be ample. And then just running the resistor. I tried it with a potential meter, but yeah, they were too sensitive, and I don't see the need to have to really control the volume. I mean, it's going to be, you know, we're training, it's going to be buzzing. We just don't want it to be overbearing as a buzzer itself. So I believe this is a little bit less. It gets rid of the humming, and it sounds pretty good. So if you see, there's a very slight humming, but you're not going to hear that when you're pretty far away. And yeah, that's definitely loud enough. So we've got a good solution here. So now is to incorporate the ESP32 to preset the systems, the 1 minute by 30 seconds and so forth. Put that into a little box, and then we can wire this up, solder the resistor onto the speaker, and we should be good to go. Right, so the resistor is added onto the left, and I've shrink heated it to give it a bit more stability and make it more rigid. And on the right, I've also just attached it and shrunk rub it as well. All right, so the 2 pins have been bypassed with the capacitor. We've also grounded it out so we don't get any kind of static feedback, which you don't really hear now. We're using a bigger speaker, and I've made a little box for it. And as you can hear, it is much louder. Definitely loud enough to now use in the gym. So what we'll now do is, now that we've got the sound sorted out, we'll now focus on getting the pre-programmed IR codes done via the ESP32. Alright, so in order to pre-program it, we need to know what kind of presets we need to do with the remote in order to set the timer functions. So I've had a look through the manual and worked out that, for instance, to set it as 1 minute of training and then a 30-minute rest, we'll want to do the following. Of course, we assume it'll already be on. Then we will press int, and then we'll go to edit, and we'll always set it to 99. Then we'll go to edit, and then 0100 edit, and then 0030 edit, and then to start it, they will press OK. We'll make a button for OK, and that's it. So we'll just need to work out the IR hex codes for that. Okay, so what we've got here is I've just quickly hooked up an ESP32 with an IR receiver, and basically that's just going to feed the signal back to the ESP32, and it uses the 5-volt pin and the ground pin. And we have some very basic code here. It uses the IR library, and basically it just displays the code in both hex and decimal, which is what I've had. And as you can see here, when I send a code, you can see it lighting up, but as I send a code, you can see it displays it in different values. So that's how we're going to get the code for the buttons, and be able to reuse them to program it so that we can send those. All right, so we now have it, if you look at this, we're now sending the command 0x57 via the LED. We have an infrared LED here, and it works exactly the same as any other LED, except that you don't see the light yourself. We're sending an off or an on signal every second. It's the same signal. The clock decides which state it is in, so if it's off, of course it goes on. Just a tip, of course we can't see it, but if you use a from your phone, and I put this phone over that phone, you can see the light via your phone, so your lens will be able to pick it up. And if we look at the clock, we will see that it is going off and on. Okay, so it's just sending an off and on signal to it. So that confirms that the IR is able to send it to it, and that we're able to control it via the ESP32. So we just need to now program the preset codes to a button. Okay, so I've just mocked up this little breadboard circuit with the ESP32 and some buttons, and at the end of it a little IR LED that can send out the signal. And basically we have the 3 functions, and then we have the power, and then we have the pause unpause. So here's the clock. If we just power it on, see it comes on there, and then all they need to do is just press the button, and it's going to go through and set the value. Let me just put that back, and then we're gone. And it should be. I've disconnected the speaker because we're doing the speaker test tomorrow to see if it's loud enough. But normally it'd go beep, beep, beep at the last 3 seconds, and then off it goes. If you want to pause it, you can just press it there, and you can pause it. And if you want to change it, you pause it, and you would do a different setting. So nothing too technical or anything like that. Just basically I pre-recorded the IR signals or the codes, and then put them in so that the ESP32 can do them based on the button. And it seems to be working pretty well. Alright, so just what I've added to the setup is a little screen now so that it gets some feedback on what they press. So that, for instance, when they press the pause, unpause, they'll get an OK on that. So, and they'll also get a little buzzer to tell that they've pressed that. Also the same with off and on. And also when they press a timer, it'll tell that it's setting the timer. And then once the timer's set, it'll tell it's ready. So just a couple of little feedback items. And then it starts. Just a couple of feedback items that are allowed to do it a little bit easier. Alright, so just to briefly explain what button bounce is. Here in this example we have here a button, and here we have the power coming in, and we will have the power coming out when a circuit is made by a conductive material going across both contacts. Now when the button comes down, it doesn't immediately and in a complete fashion cover those two contacts. It needs to settle. For instance, it is not completely flat. No real product is if you look at it very, very closely. And as it pushed down, it's going to kind of warp, so you might get a tiny bit of a lift on one end and not any on the other. In more bigger commercial applications, they use stuff like mercury they coat the bottom of it in mercury, or they have other techniques they use to avoid this issue. Now we're just using a standard button, so we're going to have this kind of problem. And if you look at it, for instance, through an oscilloscope, you will see breaks in the signal, and these breaks are offs. So you will see that as it comes on, it'll go on, then off, on, off, on, off, on, off, and then eventually it will settle to an on position. So, but the problem is, because we're firing off signals when it goes on, especially with the infrared remote sensor, or the infrared LED we're using to send a signal to a receiver, we're going to be sending a signal here, and then again, and again, and again, and again. And let's say it's the off signal, and the off signal is also the on signal, then the clock's going to go off, on, off, and it's going to be very uncontrollable and not usable. So that's why we have to get past button bouncing. That's why we use the Easy Button library to do that. It basically times it out and uses a sleep mechanism to make sure that it's not within this segment that is being pressed, but that it's completed a whole press, and that any other on and offs is a deliberate press of that button. So I hope that explains it a little bit for you. Okay, so just to show you what happens with button bounce when you're in the real world, as you can see, it's now paused. The yellow button is designated as pause, unpause. If you press it, see, it's a little bit too long. See how it's kind of switching it off and off, off and off, on and off, on and off real fast. And you really have to time it. Yeah, see? So that's button bounce, and that's why we're using that class, Easy Button, with the timings to avoid this situation. Okay, so I've soldered up the PCB board onto the ESP32. So we have all the ground connections here and the different buttons and so forth, the IR light. One thing I'm going to do is I'm going to add a speaker to it, so that when the choice is made and it's done on the clock, then it actually just tells them it's done with a little oos, which is like yeah, I'm ready kind of thing for kickboxing. So I thought that would be a nice way to do it. Anyway, that's all done. I've made a little rail here for the ground, as you can see. And now ready to program this speaker in. I'm going to get that us from the trainer. So what I've got here is a little editing program, video editing. And always at the end of like a little demonstration that he's telling us what we need to do next, he's going to say that. So it's going to be around here. So what I'll do is to make it easier to manage, I'll quickly split the two sides. And if we listen in, we should see. There we go. So let's get it. If we zoom in on this, okay, we can see it's going to start about here. So let's split there, and let's split around here. All right, and if we listen a bit slower, take it down to. And a little too slow. Can't get it there. All right, let's try it here. Yeah, there we go. So you can see here when the sound waves start going up. So we just split that up. All right, let me just take care of that. All right, and then we should be around here it ends. Alright, so let's split it up there. It should be pretty good. Let's run it at normal speed. Yeah, that's it. Got a little at the end, so I want to quickly cut that out. And let's run it. That's it. Alright, so now we unlink the video, get rid of the video, we only need the music, the file. We save it as a new clip. We go to its location. Alright, here it is. Yep, and we'll call that us, which is what they're saying. It's a term used basically for comprehension in kickboxing. Oops, can't do that yet because it's in use. So we'll just copy that for now. And what I'll do is I'll convert that to C code. So if we go here, all right, it's here, and this. Right, and we want to open that with a hexadecimal editor. This one here. Alright, and we'll open the file and we'll get the hexadecimal value, and then we'll be able to use that as the code to run it. So we'll select all that. We'll do a what was it again? Edit copy as C. We've got that, and now we can just put that into Notepad and we can use that within our code. Let's have a look. Yeah, there he is, ready to go. Alright, so I've digitized the recording and I've put it onto the ESP32. And what I've done is I've had to use an amplifier, the TDA 2030, which amplifies the LM386 chip, which you can't really see on there, but it's at the bottom of that heatsink there. And so just to example, I've done it so that when you press the button, you can hear it coming out. That's loud enough at the console, and I'll be using that so that when the timer is ready and it's programmed the clock, it'll go, and the trainer knows you can press the button and it can start the countdown. Okay, so all the soldering is now done. I also do the plastic shrink wraps around the connections just to strengthen them up. This is all ready to go, and the buttons are done. The amp's hooked up, and so is the screen. So tomorrow I'll be making the box. I have the dimensions for it here, rough dimensions. And also I'll be making the speaker box to put the speaker in. And once all that's done, then I can start to put the components inside of it. Okay, so I've done all the connectors now, as you can see. so it makes it much more easier to connect and disconnect if I ever need to. And on the female sides here, for the front of it, that's all wired up. So today it will be all about connecting and testing and making sure that there are no issues I haven't thought about. So let's get on with that. Alright, so one thing I want to add is I'll put on these plastic covers, which are quite important to insulate, as you can see. So that when it's like shaking around and that, none of the connectors touch, which is something you do not want. So definitely worth the effort putting these on. And now I'll just connect them all up. Okay, so all the wiring is connected up, and yeah, it's ready to put together, and should be able to deploy it very soon once I've tested it. And the program seems to run pretty well. I did a couple of test runs. So I'll put it all together and I'll give a little demonstration of how it now runs. So now just to quickly show, I will be putting the transmitter, the IR transmitter here, directly over the IR receiver here. I'll hold it in place with the screen that'll come over here, which will work very nicely. And I'll be running the cables here outside the box, and I'll make a little connection to the control box, which is sitting there, which is coming along nicely. It's all wired together. Like I said, woodwork is not my speciality. I'll put a little cover over this, but it is currently working pretty good. So that concludes another episode of Richie's Robots. Thank you for watching. I hope you found some bits interesting, maybe about the LM386 amplifier chip. That's in a lot of low-cost solutions for sound, so you'll see that chip quite a bit in a lot of devices. The button bouncing was quite handy to know about using the easy button library in order to handle that kind of issue, because it can be quite an issue for a lot of projects. And the IR stuff, the infrared stuff, from this you can learn how to do your own IR programming, replace some of your remotes, make your own universal remote, quite a lot of things that can be done with that. But yeah, all in all, thank you for watching. I hope you found it enjoyable, and I look forward to seeing you in my next project coming up very soon. Thank you and take care.